Hello, my name is Marcin Moskała, and today I will be talking about using Kotlin Coroutines in practice. Kotlin Coroutines is a big library with many of powerful features, and in this workshop I would like to show the most essential use cases for Android and for backend. This presentation is based on my book, Kotlin Coroutines, published recently, updated for the newest version, 1.6, what makes a lot of difference because the way how we use dispatchers and the way how we test coroutines has changed a lot. The book seems to be quite a popular position already. It was also written in cooperation with many great technical reviewers, including two Kotlin Coroutines co-creators, few GDEs and great authorities, and even a Android team member who co-created a testing library for Kotlin Coroutines. So I think this is a very solid position based on my workshops, so also from the experiences of not only me teaching that, but also the attendees of the workshop that I conduct for KT Academy for a pretty long time already. I think I already taught how to use coroutines over 200 people. And you can treat this presentation as maybe a summary or maybe a cheat sheet created based on this book. I will not go here into details because we have no time for that. Everything, the details can be found over there and in the articles that I will share on this presentation. So before we go into typical use cases, short introduction about what are coroutines. Coroutines do not only exist on Kotlin. This is a general concept. To explain it, I would like to show you an Android use case. So imagine that on Android you need to fetch some data from the internet, process it and display it. So all the view modifications on Android, as on many other front-end frameworks, you need to make on a concrete thread. All the view modifications needs to happen on the main thread. It is the only thread allowed to modify the view. Okay, and that's why this thread is very special. You cannot block it, because if you block it, then your application is frozen, and you know you have application not responding. So it needs to be protected, and at the same time, you need to use it quite often. So if you want to fetch news, process, display, you cannot do that on the main thread because blocking thread would kill your application. You cannot use a different thread because showing news need to happen on the main thread. There are different ways how do we deal with that on Android, callbacks, RxJava, but the simplest one and I believe the best one is to use coroutines. So when we just need to wrap it with a coroutine. We also need to make one more modification that is not visible in here. This function cannot be a blocking function, it needs to be a suspending function, and now everything works fine. So what the hell is a coroutine? What the hell does the suspension mean? So the coroutine is a part of our code that can be suspended. So suspension is the essential concept of coroutines. So what suspension means? Suspension means that you can save this coroutine. When you suspend a coroutine, you are receiving an object that keeps references to all the local variables and the state where you stopped, and that's it. It can be stored somewhere. Formally, it can be even serialized, and it is enough to resume this coroutine. So the essence is that all you have left after your coroutine is this simple object with the essentials that can be at any point used to resume your coroutine. And that is a very powerful concept. I think to understand this, a good metaphor might be very helpful. And here I like a metaphor of machine for gaming. So threads are like those old arcade machines, or maybe not. The classic approach is like playing a game on this classic game machines. They could not be saved. The state could not be saved. You could only stop it. And there are some bad consequences of that. So first of all, you cannot play multiple games interchangeably. Okay, if you play one game, if you want to play a different game, you need to stop the previous game. You cannot keep your state anywhere. Second of all, if you want to stop playing game and do something else for some time, and you want to keep your game active, then the whole machine needs to waste resources to keeping this state alive. And this is a very good metaphor for a thread. Thread can do only one thing at the same time, and if you want to block some process, you are blocking the thread and it is wasting resources. It cannot do anything else. It is a very, very bad way to manage this thread. On the other hand, we have coroutines. So coroutines are like those games that can be saved. So whenever you suspend a coroutine, it's like saving a game. And as a consequence, you can play multiple games on the same computer interchangeably. The same with coroutines. Coroutines work on top of threads. So on a single thread, you can you can run a little bit of one coroutine, then switch to another coroutine, etc., etc. So on one thread, you can run multiple coroutines. But also, if you want to, it's possible to play a game on one computer, then save it and resume it on another computer. The same with coroutines and threads. You can run a coroutine on a single thread, then suspend it, and from this point resume on a different thread. That is a huge convenience that lets us manage our threads in much better way. The third thing is that if you wait for something, like you wait for data or whatever, you do not need to keep this machine alive. You do not need to keep any thread alive. You can let threads go and just store this continuation object. And when you need to resume, you are taking a thread and using it to run your coroutine from the point where you stopped. And this is a good metaphor for how coroutines work. Here we use a coroutine. Here we use a suspending function instead of blocking, and that is why we can run it all on the main thread, because this main thread will be used only where it is needed. So it will be used here until we send the request. Once we send the request, we suspend coroutine and the thread is free to go. Once the data are back here, we resume and we continue from this point. Okay, that's how coroutines work. What is worth noticing is that it is coroutine that is it is launch that starts a coroutine. Suspend function is just a function that can suspend a coroutine. So if I have two suspending functions, I need to start them on in different coroutines if I want them running at the same time. With that, you see, I can use one thread, the main thread, to start two coroutines at the same time. So it will first do a little bit from one coroutine, then this coroutine is suspended, so the thread can go and handle another coroutine. Once it's done, it might be waiting and doing nothing. Once the data are there, we might use this thread to resume our coroutine from the point where we stopped. So suspending functions are not coroutines. Suspending functions are just functions that can suspend a coroutine. And if you call multiple suspending functions, notice that this will be sequential by their character. So in this coroutine, I first get configuration. Once the configuration is there, I get news. Once the news is there, I get user. Once the user is there, I show them both. If I would want to do it asynchronously, I can always use async await. So this is a function, a very simple function from the Kotlin X coroutines library. Okay, two more use cases, two more examples of using coroutines, and we can start practical use cases. So the power of coroutines is that we can mimic any kind of pattern that we know from classic imperative programming into coroutines, and it will work perfectly fine. You do not need to learn about any new special tools. You can just write your code the same way as you are used to. So here I showed two patterns. In both of them I load pages with pagination, but on the first one I use a coroutine to asynchronously fetch all the pages at the same time. Yeah, so for each pages I asynchronously start the process of fetching news. I await them all, and on the end I display them all. Okay. On the second case, I do it step by step. So I first get the first page, I show this first page, then I fetch another page. Once it's there, once the data are there, I show it. So now it is synchronous. And notice that mimicking those two patterns requires no special knowledge. Those are very, very basic functions. This is how programming should look like, and this is very, very intuitive. So this was my introduction to coroutines. Time to cover the most typical use cases, and I will of course concentrate on Android and on backend, but they can also be most of those use cases are universal among all the platforms. I would like to just start with that if you are lucky, you might need to do very little to migrate from blocking codes into coroutines. So when I was migrating different backend services, it was not uncommon, maybe that most or even all of the changes I needed to apply was to just change regular functions into suspending functions. Yeah, the only thing I changed in here is that I added suspend modifier, and this is how I can change from blocking calls into coroutines, into using coroutines. Why is it so easy? Primarily thanks to great libraries that have support for suspending functions. So if you use a suspend modifier in a retrofit, then this function will not be blocking, it will be suspending. This retrofit respects this modifier. Suspending function needs to be called from a suspending function, so we use suspending functions all the way down here. And Spring Boot also respects this suspend modifier. Suspend function needs to be started from some coroutine. What coroutine? We don't care. It is Spring Boot that will handle starting that from a coroutine. And this is a very convenient situation for us. But often it might not be enough, and we need to know how can we cover different use cases on different layers of our applications. Both Android and backend applications typically are divided into 3 layers. The top layer is called a data or adapter layer. This is where we have our repositories, providers, adapters, their data sources. This is where we wrap external libraries to be able to modify, to communicate with a database, with other services, with operating system, or with whatever else. In the middle we have domain layer. This is where we have our business logic, so services, use cases, interactors, etc., etc. And on the bottom we have presentation or API layer. This is where we have controllers, presenters, and view models. This is where we need to start coroutines, and this is what we are going to talk about in the end. So let's start about data layer. And here, as I said, if we are lucky, all we need to do is to use suspend modifier, or maybe to use a flow, and that's it. More and more libraries have support for suspending functions, have support for coroutines, especially on JVM, primarily on JVM. And so less and less often we need to do something more in this layer. It's best to use built-in support because it's generally implemented really, really well. Okay, so use proper libraries, and this part will be easy and well implemented. Okay, though if you do not have such a comfort and you need to call an external library that does not support coroutines, there are two typical cases where you need to do something. So the first one is where you have a callback function. So you need to call a callback function. So migrating from a callback function into a suspending function is relatively easy, though it needs to be remembered. What the typical pattern is as follows. You need to call suspend cancelable coroutine. This suspends a coroutine, but before it suspends a coroutine, it calls this lambda expression. So what do we do inside? We start our callback function, and we set that in case of a success, we should resume with the data that should be returned. In case of an error, we should throw an exception, and here we specify what exception should be thrown out of this suspend cancelable coroutine. Okay, this is the basic pattern. If you want to learn more about that, there is a published chapter, so a chapter that I published so that anyone can access that. How does suspension work in Kotlin Coroutines? You can find the link in here. I hope you will check it out, and this explores deeply how does suspension work and also how cancellation works, and we reach that step by step. If there is a way to cancel your callback function, the best practice is to also set invoke on cancellation, that is covered in the cancellation chapter, and specify and cancel your call. Why do we do that? It's very often that, for instance, in Android, you open some window and you immediately exit that. So you start some processes, but when you exit that, you should end these processes. If you do not end these processes, then they will be active. You will be fetching data, processing data for the view that does not exist. You will try to update the views that does not exist. So this is a big problem on Android. We need to have a proper cancellation mechanism. Coroutines give us very, very good cancellation mechanism, but on our wrappers around callback functions, we should also set up this invoke on cancellation to cancel callback call in case of coroutine cancellation, so that we are not wasting resources, so that we are not waiting for data that are not needed anymore because they will be ignored anyway. Okay, so this is how we wrap callback functions. Another typical use case is when we need to wrap over some blocking call. Yeah, when you have a library that has a blocking functions. So we do not like we do not like calling blocking functions in a domain, in the coroutines, because if we do not control what dispatcher is used, if we don't control what pool is used, what pool of threads is used, then we might block some important thread, and this should never happen. Okay, so the best practice is that if you have a blocking call, this blocking call needs to be wrapped into a suspending function that is wrapped with context, as you can see in here, and you should use a dispatcher that is suitable for blocking calls. Okay, the most basic dispatcher for that is dispatcher's IO. Okay, dispatcher's IO is suited for blocking calls. Okay, though dispatcher IO, so this is how you wrap over the blocking functions. Though dispatcher's IO has a certain limit of threads, so it's fine if you are using it to some limit, but if it is used too much, if it is used by all the if it would be used by all libraries and all your functions, then you might exceed this limit. It's 64 by default. You might exceed this limit. So a good practice is that if you expect that this function might be called quite often and might block a lot of threads, it's better to create your own dispatcher with its own independent limit of threads. I will just add in here that threads in those dispatchers are really well managed. They are all shared between dispatchers. I mean, not all, but the dispatchers IO and dispatchers default and most essential dispatchers share those threads, they reuse them, they create them on demand, and the thread management is really smart and powerful. So, and you in the changing threads generally does not happen when it's not needed. So you should not be worried to use such a wrapper with context dispatcher IO or with context and your own dispatcher. This is a really well thought through feature that is deeply explained in my chapter Dispatchers. It's one of the chapters I'm most proud of, and it's also published online, so you can find it on KT Academy article CC Dispatchers. Two more dispatchers I want to mention is dispatchers default that should be used for CPU intensive operation. It's optimized for CPU intensive operations, and you also might wrap some CPU intensive operations with the following with context dispatchers default. And another one is dispatchers main. If you need to update the main view and you are not sure that it will be called from the main thread, then the main dispatcher, then you should use dispatchers main immediate. It's more convenient to set dispatcher yourself with this with context. Kotlin is smart. It will not change dispatcher if that does not need to. Okay, if the dispatcher is already correct, it will reuse it. It will not change thread if it does not need to. So if you are, for instance, on dispatchers IO and we move to dispatchers default, we'll most likely not change thread. We'll just change from what limit do we use. So Kotlin dispatchers are really smart. And this wrapping costs very little, but it gives us a lot of safety because it makes sure that this code will be called in a proper dispatcher. Okay. So this was about data layer. Now we can move into the domain layer, and this is kind of the easiest and hardest layer at the same time. Easiest because we generally, when we move from blocking calls into regular calls, we generally do not need to do anything in here. You know, we can only add suspend modifier where it is needed because suspending function needs to be called from a suspending function. But outside of that, nothing needs to be done. Okay, but a lot can be done because we have new shiny tools. With coroutines, we can introduce easily concurrency at any point. We can control the cancellation for better memory management, etc., etc. So 2 words about that. So first of all, if you want to introduce concurrent processing or maybe concurrent calculation, asynchronous calculation, you need to wrap function with a coroutine scope. And then you can use async await inside. This coroutine scope is needed to create a scope. It is needed to have a proper behavior. The essence is that those two functions, the only difference between them is that this function is sequential. Yeah, so if this takes 1 second and this takes 1 second, then this function will take 2 seconds. While this one is simultaneous, so if this takes 1 second, this takes 1 second, then the whole function will take 1 second because those two things will happen simultaneously. Okay, that's the only difference. Everything else stays exactly the same. So if you have an exception in one of those, the exception is thrown out of the function, the same as in here. The cancellation works, exception handling works, everything basically works, and that's how we want that. Though there are some small consequences that needs to be understood at this point that are not understood by many languages supporting async await. So imagine that you start this function, you try to get profile, but you have an exception. Okay. So in such a case, you will never try to calculate friends. Okay. The same in here, but in this case, you calculate those two things at the same time. Yeah. So you start those two processes at the same time. And let's say that one of them is having an exception, maybe the profile. So when this one has an exception, the other one is not needed anymore. It could be cancelled. And thanks to the coroutine scope, it will be cancelled, okay? So coroutine scope assumes that all its children are needed. If any of them has an exception, it cancels others as well. That's how coroutine scope works. That's a really good mechanism for our memory management. Although, if you want to change this behavior, we'll soon see you might use a supervisor scope instead. Okay. One thing that, much more about coroutine scope and other coroutine scope functions we'll discuss next in the chapter, also published chapter, coroutine scope functions. You have a link below. So another thing you might want to modify, imagine that you want to fetch for each category requests, but what if there are hundreds or thousands of categories? So do you want to send thousands requests at the same time? Probably not. It would be better to limit this concurrency, and for that you can use a flow, flat map merge, where you fetch offers concurrently, but with a concurrency limited to 20. That's a pattern that you might get back to when you will be doing programming. Another thing is that, as I mentioned, when in coroutine scope, one child has an exception, all the others are cancelled too. If you want to stop this mechanism, if you want your child to be independent, this is what we use in a situation like this one, when you start independent tasks. In such a case, you can use supervisor scope, and now you start many lunches, but an exception in one lunch will not influence the others. If you want to ignore exceptions in async await, then you need to do two things. So one of them is that you need to use a supervisor scope instead of coroutine scope, so that exceptions in async are ignored. And the second thing is that you need to wrap wrap with try catch your await, because imagine that you try to calculate some data, you have an exception, yeah, but this exception is silenced by supervisor scope, okay. But when you await this exception, you still do not have data, you have an exception. So this exception will be thrown out of here, and we can handle it in here. So another pattern worth remembering. And the last thing from this layer that I wanted to mention is that if you want to set up a timeout for some execution, you can use with timeout or null. With timeout or null, after 5 seconds, this implementation after 1 second will cancel the body and return null. This is how it works. Okay, this was it about the domain layer. Time to talk about the presentation layer. So how can we start all that? So this is where we define controllers, presenters, view models, handlers, etc., etc. And again, if we are lucky, if we use Spring Boot, if we use Ktor, then we can just use a suspend modifier, and coroutines creation will be handled by our library, by our framework. But in other places and in Android, you do not have such a comfort. You need to start your coroutines by yourself, and to start a coroutines, to call launch is a basic way to start an independent coroutine, to start a coroutine. To be able to call launch, you need to have a coroutine scope. This is what we need to start with. You can also start with run blocking, but this is something we are avoiding on real-life applications. This is useful on unit test, run blocking, or run test. This is something that can be used on example or maybe some crude code, but when we use a real-life applications, run blocking should be avoided. Sometimes we cannot avoid it, but in general it should be avoided. So what we should start with is coroutine scope, okay? So how can we create a coroutine scope that we can use to start a coroutines? So this is an object we will be starting our coroutines on. On Android, you do not need to worry about it in general. You can use view model scope or lifecycle scope from KTX. Though now you might be wondering how this scope is created, and we'll talk about it soon. And when you have a scope, you can just launch a coroutine on that. Yeah, so you launch a coroutine. This is how you start a coroutine process. So how do we create a scope? So there are a few elements that you can add to the scope. You need to compose them however you want. The typical way to create a scope is to use this coroutine scope function. This is a fake constructor because coroutine scope is an interface. More about it in the effective Kotlin. So with this coroutine scope function, you create a scope, and the standard thing that we place inside is a supervisor job. We need to use it because without it, an exception in one coroutine started on this scope will break this scope and will break other coroutines as well. We do not want to do that. If we typically want to have independence between different coroutines started on this scope. So it is practically a standard to use a supervisor job in here. Another thing that we typically use is that we specify some dispatcher. On Android, it is typically dispatcher's main. On backend, it is often dispatcher's default or a dispatcher's IO limited to a certain number of with a limited parallelism of some concrete size. I would rather stick to dispatcher's default. This is a good dispatcher for backend. Yeah, this is optimized for CPU intensive operations. We assume we'll never block threads on that, so it should be optimal for backend applications. Another thing that we often do is that we often set up to cancel coroutines started on a scope when they should be cancelled. So this is what we do on Android. When view is destroyed or view model is cleared or presenter is cancelled, we cancel all the coroutines started on the scope. We do that by using cancel children. So this way we cancel the coroutines started on the scope, but not the scope itself. You could also just call scope.cancel, but if you do that, remember, you cannot use this scope anymore. If you cancel children, then scope can be still used. It is generally safer. And the last element that might be added is an exception handler. We use exception handler to specify a default behavior that should be invoked when an exception occurs. So what do we use it for? We typically use it for some logging, for some sending exceptions to an aggregator, to Firebase, to Sentry, etc., to showing universal information, for showing a dialog, snack bar, toast, whatever, you know. Some applications have this request, but whenever you have API exception 401, then move into the logging screen or something like that. This is what we can use our exception handler for. So now let's see it in practice. So let's start with a Spring Boot application. Oh, sorry, there is a dedicated chapter about constructing scope, also published, so you can read it online, a link below. So a Spring Boot example, we construct a scope in a configuration. I used a dispatcher with parallelism limited to 5. I could use dispatcher's default instead. It depends on what do you want. In this case, I wanted dispatcher IO. Then I specify exception handler that sends exceptions somewhere, and here I construct a scope out of that. I use a supervisor, job dispatcher, and exception handler. And here I inject this scope and I use it. So when I have a coroutine scope, I can just launch coroutines on that. And each of those coroutines will happen independently. It's a bit like starting a thread, yeah, but it's not starting a thread. It starts a coroutine, so it's much lighter and much more efficient. In case of Android, we more often we might specify a scope in some base view model or base presenter or base controller, whatever pattern do you use? Here, the typical dispatcher on Android is dispatcher's main. We also use supervisor job, and we might also define exception handler. That shows our exception. In this case, sets it to some live data that can be observed by our maybe base activity or base fragment. And I also cancel children in case of this view model being cleared. Okay, as I said, we often do not do that nowadays because we use view model scope. But how does view model scope look like? And if you check out its implementation, you will see that it just creates a closable coroutine scope. It just creates a coroutine scope with a supervisor job, dispatcher's main immediate, and also it cancels the scope in case of this view model being closed. So it's nearly exactly what we did in here. It's just that in here we also had this exception handler. Outside of that, everything else is in the view model scope already. Okay, so this is quite convenient. Okay, and this is what I wanted to tell you about the most important use cases. I would like to close this with a little bit about testing, because testing is very important for us. And imagine that you have the following function that gets profile, gets friends, and returns user. This is a suspending function. Those are suspending functions. I just want you to know that testing that is nearly identical to testing blocking functions, you know. Yeah, the only difference is that you need to wrap the code with run blocking because you need a coroutine, you need a suspending scope in here. So you wrap everything with run blocking, and everything else is just the same, you know. You set up fakes, you call your function, you check result, and you can call other functions, check their results, etc., etc. It is exactly the same as classical unit tests for blocking functions. Another example here, a bit more complicated. It's a simplified test case from KT Academy applications. So I set up a situation that there is some user. I verify, I make a situation where the update request is sent. And on the end, I verify that these update data were correctly modified our user. Yeah, so this is again exactly the same testing as we did before using coroutines. So testing coroutines is easy, but even more, coroutines offer us great tools that we did not have before. And for that, I would just want to show you one example. So here is a function you already know, and here's another function you already know. As I told you, those functions are identical in all the ways except for one. So their behavior is absolutely identical. They create the same user the same way. The only difference is that this one is sequential, and the other one is that this one is simultaneous. So in other words, if function get profile and get friends are immediate, there is no difference between those two functions. Absolutely no difference. It's impossible to show the difference, okay? To show the difference between those two functions, those functions need to take some time. If each of those functions take 1 second, then the first function needs 2 seconds, the second function needs 1 second. This is the only way to show the difference between those two functions, because between sequential and simultaneous function, okay? So how can we test if something is truly simultaneous? We need to add waiting, you know, we need to make those functions take some time. But if we do that, then our unit tests take too much time. They start taking more time than we want them to. We want them to be immediate. We do not want to wait real time. So what's the remedy for that? The solution is very simple. You just need to use run test. Run test is a very special function that uses a very special dispatcher that makes your function operate on a virtual time. And when you make those functions delay they will not delay a real time, they will not wait a real time, they will be immediate. But they will push a virtual time forward. And that's why those functions will be immediate, but at the same time, you can precisely check how much time would they take if they were real functions. And you can check precise numbers because, you know, it's a virtual time. So you can verify that if you would wait 1 second in each of those functions, the first function would take 2 seconds precisely. You can see it's assert equals. It's not like a round or something. It's precisely 2 seconds because it's a virtual time. And the first one, if and the second one, if it is simultaneous, should take precisely 1 second. And this is a very, very powerful way to test time dependencies, to test what happens after what. There are much more, you know, tools for testing that we can use. We can verify what happened at what point of time pretty easily. You can operate on the virtual time wherever you want. That's very, very convenient. But it is all described in the chapter testing Kotlin Coroutines, and you need to read it if you want to learn more or attend my workshop. Okay, so that's about testing. A big picture on the end is that in applications, in using coroutines, we typically start everything on a coroutine scope. On a coroutine scope, we launch coroutines and we call suspending functions. We very often have suspending functions calling suspending functions, but if we need to introduce concurrency, we use coroutine scope functions like coroutine scope, and on those functions we call async, and then we call suspending functions there. From time to time, where we need to modify something, like when we modify a context or set a timeout, you just use a coroutine scope function and call suspending functions inside. So this is how our tree of what calls what looks like. There is also run blocking and run test that should be avoided. It is a bad smell to use that. In some cases we need to use it, so it's not a rule that you should never use it, but you should avoid using that whenever it's possible. You should not use it, although it's very useful for showing a simple cases, for a crude examples, and also for unit testing, run blocking for a regular call of or for a regular call, or run test to call it in a special virtual environment, operating on a virtual time, not a virtual environment, but on a context operating on a virtual time, what gives us some extra capabilities for testing. That is everything from my side. More can be found on the book. It was recently published. I am very proud of that. I think it's very strong position, and I can recommend that to you at this moment. Thank you for your attention. I hope you learned something today, and I hope that you will find Kotlin Coroutines nice and pleasurable to use. Thank you for your attention. Oh, and I will publish my slides on at Marcin Moskała Twitter, so you can find them there. Thank you for your attention, and I wish you a happy Kotlin.